Okay, so let's look at some examples here of using U-substitution. And we'll first put this in here and actually just do U-substitution, and then we'll look at why it is we have to do U-substitution on some future ones. So let's start by looking at the integral of 3x squared minus 5 raised to the 7th power times 6x with respect to x. And we're going to do a u substitution on it. Well, the first thing we're going to need to do is to pick our u. Now, u is usually the bigger piece or the piece that's being raised to a power. So in our example right here, I would pick u to probably then be the 3x squared minus 5. And if that's u, then the u prime, remember we need that u prime in there, so the u prime that we're going to need will be a positive 6x. Now let's take those two things and look and see what we have in our integral. This first piece right up here, looking back to my integral, looks like a u to the 7th. Then my 6x becomes my u prime. Now, remember the form for this. The form for this says that the integral of u to the n times u prime dx. And that's exactly what we have here. So once we know what we have, we just need to simply write this as the u to the n plus 1 over n plus 1 plus c. Notice here that the u prime, even though we have to have it, does not come out in the answer. What actually comes out in the answer here, and I'll leave this in terms of my u and then we'll put it back in a minute, is going to be u to the 8th power over 8 all plus c. And then putting back in my u, and I tend to like my fractions in front, I would rewrite this as a positive 1/8 times our u choice, which was 3x squared minus 5 raised to the 8th power all plus c. Remember again that even though, looking down my formula down here, even though I need the u prime, it doesn't come out in the answer. That's part of what we have to fit the form. So just like when you take a derivative, you have to add in a u prime. When you integrate, you're going to need a u prime. Let's look at another example, and we'll talk about the process. That is, how do we know to use this? Let's try something like the integral of 2x squared minus 4x plus 1 in parentheses, then 4x minus 4 in parentheses with respect to x. Okay, and we're going to do a u substitution on this. So, oh, and I'm sorry, I did say raising that to a power. Let's take that first parentheses and let's raise it, say, to the 9th power. Okay, so again, I'm going to start by picking my u. U is going to be the bigger piece and or the piece that's being raised to a power. So in this case, that's a 2x squared minus 4x plus 1. And if that's u, then the u prime that goes with this is just the derivative of whatever I pick for u, and that is a 4x minus 4. So when I look back up to my original integral up here, I see that this piece looks like a u to the 9th, and there is my u prime dx. And that does look like it fits the u substitution form. And I'm going to write what this looks like in terms of u. So when I integrate u to the 9th times u prime, remember we need the u prime. It does not come out in the answer. We simply get 1/10 u to the 10th all plus c. And then putting back in my u, this is going to give me 1/10 times my u, which was 2x squared minus 4x plus 1, all raised to the 10th power plus c. Now, we're going to do some more examples of this, but at some point we have to start looking at not only how to do each of the different integration rules that we wind up with, but when to use them. And I call that a process. So as we go through and we learn different methods for integrating, we're going to continue to add them into what we call our process that we have for integrating. The first thing we need to do is we need to try to fit a basic rule. And we saw what our basic rules were. We were given those for our last test. They were x to the n, 0, constants, and the trigonometric forms. And there are several things we can do to make it fit a basic rule. We might have to multiply. We might have to divide. Oops, sorry about that. Divide. We're going to find that there are lots of other things that we can actually do as we go through this. I'm going to erase this word because it came out pretty bad, but that we can do to also fit a basic rule. But for now, basically, we're going to multiply, divide, maybe split the fraction. For sines and cosines, we might convert to sine and cosine. We might use the identity that the sine squared of x plus the cosine squared of x is equal to 1. All the things that we saw in our last section for module test 1. And if that does not work, and we can't do any of those things to make this fit a basic rule, then what we're going to do instead is a U-substitution. It's going to be second on our list because, as I said, as we go through these sections for this next module, you're going to see that every basic rule we come across has that U-substitution rule associated with it. And so the big thing to remember here is when you are using a U-substitution, in all cases, we're going to need a U and a U prime. Those are the two important things that we need in order to make that U-substitution work. So we're going to spend some time in our next video just looking at problems, and I'll go through a large multitude of problems so you can get an idea of how these things are going to work.